Hey friends, and welcome, and in this video we'll be looking at the 2020 ECZ GCE Mathematics Paper 1. So we'll be looking at the 2020 ECZ GCE Mathematics Paper 1. So let us get into solving some math. Bring your thinking caps and have your thinking caps on, and let us work together and finish this paper in as fast as we can. Okay. So let us get to solving the paper. Let's look at question number 1. So question number 1. Question number 1 is saying simplify 2a plus b minus a close brackets minus 2b. So we're given 2a plus open brackets b minus a close brackets minus 2b. So this is basic algebra. All you have to do is group the like terms and you have simplified it. So we have 2a. So the first thing that we do is we work with the brackets. So we remove the brackets that we have. So plus b, then minus a minus 2b, right? And we group the like terms. So we've got an a there and we've got an a there. So we will have 2a minus a plus b minus 2b. We work out the problems that we have. So 2a minus a gives us a, b minus 2b, b minus 2b. So 1 minus 2 gives us minus 1. So we have minus b. And we investigate and try to check if this can be simplified further. And by the look of things, it cannot be simplified further. So therefore, we have simplified our question to a minus b. So therefore, simplifying this gives us a minus b. So we can move on to question number 2. So here's our question 2. Our question number 2 says evaluate 64 over 125, and this is always the power negative 1 over 3. So we have 64 over 125 brackets, and this is always the power 1 over 3, negative 1 over 3. So how do we solve this problem as grade 12s? How do we solve this problem as candidates for the grade 12 final examination? So the first thing that you need to understand is that when you have any number raised to a negative power, it simply means, for example, you have 2 raised to the power negative 1. Whenever you have a negative power, it simply means that number that you have is a denominator of a fraction where the numerator is 1. So if you have this, it simply means this is equal to 1 over 2 raised to the power 1. And this power becomes a positive. So if you have 3 raised to the power negative 2, this is simply the same as 1 over 3 squared, right? If you have 24 raised to the power negative 3, this is equal to 1 over 24 to the power 3. If you have 10 to the power negative 1 over 6, this is simply the same as, yes, 1 over 10 to the power 1 over 6, right? So similarly with what we have here, we have 64 over 125, and this is all raised to the power negative 1 over 3, right? But we can distribute this power to each and every number that we have inside these brackets. So we'd have 64 to the power negative 1 over 3 over 125 to the power negative 1 over 3, right? And from what we've just said, we agree to say when you have a negative power, it simply means that number is a denominator with a numerator as 1, and the power becomes positive. So this is simply equal to 1 over 64 raised to the power 1 over 3. So this power has now become a positive power, right? And we have, so we can say multiplied by, so this in itself is 1 over 25, 1 over 125. So we'd have 1 over 125 raised to the power negative 1, raised to the power 1 over 3. So the negative disappears and you'd have 1 over 3, right? But this in itself is telling you to say this denominator that you have there goes on top and this numerator comes down. So you'd have 1 over 64 to the power 1 over 3 multiplied by, this goes on top, you'd have 125 to the power 1 over 3 over 1. And when you have 1 over 3 as a power, it simply means it is simply the same as the cube root of a number. So cube root of 64 multiplied by the cube root of 125 over 1, right? And we would then have 1 over, what is the cube root of 64? What number do you multiply 3 times to get 64? So when you multiply 3 times, you get 64. So the cube root of 64 is simply a 4 multiplied by, what is the cube root of 125? The cube root of 125 is 5. So when you multiply 5 3 times, you get 125. So we'd have 5 over 1, right? And this simplifies to 5 over 4. And if you want to go further, you'd leave this as a mixed fraction in the form of 1 over 4. So either this or that is correct, and hence we have evaluated this question that we have been given in this paper. So you can pause the video and try to understand it. If at all you haven't gotten the concept, you can pause the video, try to understand it, and we can move on to question number 3. So grade 12, here's our question 3. Question 3 says, given that the lines 3y equals to x plus 6 and y equals kx plus 12 are perpendicular, find the value of k. So given that the lines 3y equals x plus 6 and y equals kx plus 12 are perpendicular, find the value of k. So we're given 2 lines, right? We're given a line with the equation. The first line has the equation 3y equals x plus 6. And the second line that we have has the equation y equals kx plus 12, right? And we're given a condition to say these 2 lines are perpendicular. Now, what do you know about perpendicular lines? What do you know about lines in general in coordinate geometry? So when we talk of lines, we agree to say lines have a gradient, and the gradient is simply how steep the line is. And when we talk of perpendicular lines, well, when we talk of perpendicular lines, we are simply talking of lines that are meeting at 90 degrees. So you have 2 lines, and the angle in between the 2 lines is 90 degrees. So assuming this is line 1, this is line 2, we would say line 1 is perpendicular to line 2, right? And we're told to say this line is perpendicular to this other line that we're given. And the gradient, the relationship between the two gradients of two perpendicular lines is that when you multiply the gradients, so let's say m1 multiplied by the gradient of the other line, m2, the product that you get is always a negative 1. Okay, so when you're dealing with perpendicular lines, the product of their gradients is always negative 1. So now let's see how we can work with that information and solve this question. So given that lines 3y equals to x plus 6 and y equals kx plus 12 are perpendicular. So the first thing that we need to do is find the gradient of this line and find the gradient of this line. So remember this equation, y equals mx plus c. So this equation gives us the equation of a straight line. And whenever you have an equation of a straight line where y is the subject of the formula, the coefficient of the variable x is always the gradient. So this number that you would have there, our m there, is always the gradient. So the first task that we're going to have is find the gradient of this line and find the gradient of this line. So the gradient of this line would be found by making y the subject of the formula. So we'd have y equals 1 over 3x plus 6 over 3. Do you understand why we've done that? So we've agreed to say y should always be the subject of the formula, and to do that we would have to divide throughout by 3. So 3y divided by 3, x divided by 3, and 6 divided by 3, and we would have this. So according to this equation, the value of the coefficient of x is always the gradient. So the gradient of this first line is, so we'd say m1 equals to, the coefficient there is 1 over 3. So we would have 1 over 3 as our gradient 1. And our gradient 2 from equation 2 is, we've got y equals kx plus 12. So what is the value of m? What is the value of the gradient? It is k, right? So in this case, m2 equals k. And remember to say these two are perpendicular, so the product of the gradients m1, m2 should be negative 1. So we will have then m1 multiplied by m2 being equal to negative 1. What is our m1? Our m1 is 1 over 3. And what is our m2? Our m2 is k. See that? And we'd have negative 1. So then we have k multiplied by 1 over 3 gives us a k over 3 equals negative 1. And therefore k would be equal to negative 3. I hope you won't find any difficulties in tackling this question. So the first thing that you do is find the values of the gradients, multiply the two gradients, and you get the product of, you get a product that is negative 1. And that is how we find the value of k. So we can move on to question number 4. So here's our question number 4. Question 4 says, factorize completely 6ax minus 4ay minus 3bx plus 2by. Factorize completely 6ax minus 4ay minus 3bx plus 2by. So what we have there is 6ax minus 4ay minus 3bx plus 2by. So how do we do it? So let us factorize these parts. And we factorize this part. All right. So what do we have common in or between these two? So we've got a 2 that can go into both coefficients that we have. That's 6 and 4. So we would have a 2 outside. What else? We've got an A. A is common in both. So we'd have A, right? What else is common? Well, I believe there's nothing else that's common. So then open our brackets there and would have what remains when we take out the 2 and the A. So 6 divided by 2 gives us 3. What else is remaining? The X. We haven't touched the X. So we'd have X. Then minus what remains. 4 divided by 2 gives us a 2. Take out the A. What remains? We got Y. We close the brackets. Then we come to this other part. So we'd have minus, right? What is common? Is there any number that is common in the two values that we have been given? Is there a number that can go into 3 and 2 without leaving a remainder? No. Anything else? Do we have anything that is common? Well, the B is common, so we'd have minus B. Anything else? Well, I can't see anything, and I hope you can't see anything too, because there's nothing that's common. So then open the brackets. What remains there is a 3x, right? And since we have a negative there, for us to get a positive there, we'd need to have a negative there as well, okay? And what is remaining after taking out the b would have 2 and y, so we'd have 2y. And we close the brackets. Are we done? Well, let's critically analyze what we have now. You find that this part and that part are the same. The values in the brackets are the same on both sides of, or rather on both sides that have been factorized. So if these two are the same, then we can factorize what's outside. We would have 2a minus b. We put this in brackets, we close the brackets, and then since these two are the same, we would pick only one of them and have 3x minus 2y. And that is how we factorize completely, okay? And that is how we factorize completely. So we can move on to question number 5. Here's our question 5. So question 5 says, given that A is a point -2, 1 and B is a point 1, 5, find the magnitude of the distance AB. Do you understand that? So these two lines are simply saying the magnitude of the distance AB. What is the distance AB? So remember this is simply asking us to find the distance between A and B. Do you know how to do that? So it's quite easy, and we will run through it together. So it's saying find the magnitude of AB, the distance from A to B, right? So how do we find the magnitude of the distance AB? So first, let's collect the information that we've been given, the data that we've been given for point A. So here's what we're looking for. For point A, we have -2, okay, let me just write them a bit lower. So for A, we have -2, 1, and for B, we have 1, 5. So once you see numbers arranged in such a format, in such a way, where we have a number, a number, you should know to say we are dealing with coordinates. And once you realize to say we're dealing with coordinates, you should remember to say coordinates have x and y values. So we'd have x, comma, y. Remember this? So we've got our x values there, and we've got our y values down there. So how do we find this magnitude? So to find the magnitude AB, we would have to say this is equals to the root of a whole big square root, and we would have x minus x, this should be in brackets, squared, plus y minus y, brackets, squared. So we'll have to get the difference in our x values and then add that to the difference in the y values, and both would have to be squared. Okay, so let's do that. We'd have root of, what are our x values? So everything under the x is x, everything under the y is y. So for x we'd have minus 2, negative 2, minus 1 squared, plus, for our y values we've got 1 minus 5 squared, right? I hope you've seen where we've gotten them from. So we've said minus 2 minus 1, 1 minus 5. And that is how we have that. So negative 2 minus 1 gives us minus 3, and this is squared, plus 1 minus 5 gives us a 4, minus 4, sorry, and this is squared. So what is minus 3 squared? Minus 3 squared, or rather 3 squared gives us a 9, plus 4 squared gives us 16, which then gives us 25. So we'd have root of 25. So therefore, the magnitude of the distance AB is equal to, what is the square root of 25? What is the square root of 25? This should be easy grade 12. The square root of 25 is 5. So therefore, the magnitude of the distance AB is 5. You can actually say 5 units if you want. And that is how we solve and how we work around question number 5. So can we move on to question number 6? Yes. If you have any problems, please pause the video and rewind and try to grasp the concepts that we're trying to work around with. So we can move on to question number 6. So here's our question 6. Question 6 is saying, use set notation to describe the shaded region in the diagram below. So use set notation to describe the shaded region in the diagram below. Use set notation to describe the shaded region in the diagram below. So the shaded region that we have is there. Do you see that? And let's notice something about this shaded region. So this shaded region is not in any way part of set P. Do you see that? So that already is a clue, and that is the first thing that we're going to write. We would have P complement. You see that? Because this shaded region is in no way touching, or is in no way affecting set P. So P complement. Then it doesn't just end there, because if we just said P complement, then everything outside P would have to be shaded. But it's only this part that is shaded. So P complement intersection. Then we open our brackets. What else is shaded? Oh, what is shaded? Well, the intersection between set Q and set R is shaded. So we'd have P complement and intersection Q intersection R, because this part that we have shaded is Q intersection R. Do you see that? Q intersection R is what is shaded. So we'd have P complement intersection Q intersection R. And that is that about question 6. So this one is quite straightforward. It just requires you to see and to have better vision. So the first thing that you'd notice is P isn't in any way shaded, and the only shaded region that we have is Q intersection R. So we'd have P complement, which is saying everything else that is not in P but is in Q intersection R. You see that? So we can move on to question number 7. So grade 12 series of question 7. Question 7 is has got 2 parts. The first part is saying, given that, okay, so the general question is saying, given that A equals 2, 3, 1, 0. So what is that? That's a matrix. So we're dealing with matrices. So given that matrix A equals 2, 3, 1, 0, matrix B equals -1, 0, x2, and matrix C equals 7, 6, -1, 0. So the first part of the question is saying, find CT. Well, what does a T represent? What does that T mean? So CT is simply saying, find matrix C transpose or C transpose. So what does the T represent? It simply means transpose. And what does transpose mean? When we talk of transpose in matrices, we're simply talking of a way in which we alter the matrix in such a way that the rows become the columns and the columns become the rows. So we just switch those things up. And this is a very simple question, and let us see how we can transpose a matrix. So the first thing is we need to identify matrix C. Which one is matrix C? Matrix C is this one here. So for A, we are asked to find C transpose. So whenever you see that T, remember to say we're dealing with transposing a matrix. And our matrix C equals 7, 6, -1, and 0. So firstly, let's identify our rows and our columns. So which ones are rows? The rows are these ones. So these are rows. And which ones are columns? Well, the columns are the vertical arrangements of the numbers. So these are columns. So what do we have in our rows? In our first row, we've got 7 and 6. In our second row, we've got -1 and 0. And in our first column, we've got 7 and -1. Second column, we have 6 and 0. So to transpose this, what we're talking about is simply inverting this matrix in such a way that the columns that we have will now be the rows, and the rows that we have will now be the columns. So let us see how we can do that. So 7, so C transpose, let's write it here. C transpose is therefore equal to, so this is a row, it will now be a column, right? And this column will now be a row. So these columns will now be the rows. So we've got 7. If you notice, the 7 will still be there, and then this -1 will come there. So this column that we have has now become the row, right? And this other column will now become a row as well. So we have 6 and 0. So if you've noticed, the rows that we had were 7 and 6 and -1, 0. The rows have now become the columns. And the columns that we had, 7, -1, 6, 0, have now become the rows. And that is that about transposing matrices. Nothing so difficult about it. And we can go on to the second part of the question, which might be seen as a bit more involving than the first part. So the second part is saying, find x for which AB equals C. AB equals C. So what do we mean when we say AB? AB is simply saying matrix A multiplied by matrix C is equal to matrix A multiplied by matrix B is equal to matrix C. So we are multiplying A by B. So to find AB, the first thing that we do is finding AB. So AB is therefore equal to, what is our matrix A? 2, 3, 1, 0, right? And we've said AB is simply saying A multiplied by B, so we'd have a multiplication sign there, and we'd have our B, which is -1, 0, x, 2. Do you see that? Okay, so now we can continue, we can move on. So to multiply matrices, and I hope you can remember this, we said we multiply the rows by the columns. The rows by the columns. So we multiply this row by this column, and this row by that column, and this row by that column, this row by that column. So the first row is 2 and 3 will be multiplied by the first column, which is -1x. So we'd have 2 multiplied by -1. So this is okay. Then, as long as we're dealing with the same row and the same column, we would have to add. So plus 3 multiplied by x. So 3 multiplied by x. Then we move on to the next column. So 2, 3, 2 multiplied by 0 plus 3 multiplied by 2. 3 multiplied by 2. So we're done with this row, and we can move on to the next row, which is 1 and 0. So 1 multiplied by -1 plus 0 multiplied by x. 0 by x. Then 1 multiplied by 0. 1 multiplied by 0. Then 0 multiplied by 2. So plus 0 multiplied by 2. And what follows from there, then we work it out. So we'd have 2 multiplied by -1 gives us -2 plus 3 multiplied by x gives us 3x. 2 multiplied by 0 gives us 0 plus 3 multiplied by 2 gives us 6. 1 multiplied by -1 gives us -1 plus 0 multiplied by x gives us 0. 1 multiplied by 0 gives us 0 plus 0 multiplied by 2 gives us 0. And after carefully working this out, we can't add these two because they are not common factors. They have different variables. So we'd have -2 plus 3x still remains the same. 0 plus 6 gives us a 6. -1 plus 0 gives us -1. And 0 plus 0 gives us 0. Okay, so according to what we've been told, AB equals C. So AB equals C. Have we found AB? Well, our AB is there. Do we have C? We have our C there. So what is our AB? We've got -2 plus 3x. We've got -1. We've got 6. And we've got 0. This is our AB. And we've been taught to say it is equal to C. Our C is 7, 6, -1, and 0. Okay, sorry for that, we ran out of space. So if you've noticed, this 6, let's write it in a different color. This 6 is corresponding with this 6 here, right? This 0 is with this 0 here, right? This -1 is with this -1 here. And this -2 plus 3x is supposed to correspond with the 7. Do you see that? So you find that 3 out of the 4 numbers that we have in the matrices are already equal. So this is already telling us to say we've done the right thing. So now we are tasked with finding the value of x. So all we have to do is equate this -2 plus 3x to 7. So we would have -2 plus 3x being equal to 7, right? We group the like terms, we would have 3x equals 7 plus 2, and 3x equals 7 plus 2 gives us 9. So grade 12, what is the value of x? X is simply equal to 3. Was that hard? I hope not. I hope you don't face any difficulty in solving a similar question. So transpose, you're just changing the rows to the columns. AB, you're simply multiplying A by B and equating to C. So we can move on to question number 8. So number 8, there's our question number 8. Also quite a very easy question that we can definitely do together. So the question says, given that the 11th term of an arithmetic progression is 43 and that the first term is 3, find the, so it's a two-part question. The first part is asking you to find the common difference, and the second part is asking you to find the fourth term. Okay, so can you do this on your own? Okay, I hope you can. So if you feel you can pause the video and try to work it out on your own. So the first part is asking us to find the common difference. So let's start with finding the first part, which is the common difference. So let us collect the data that we have. So let us say data. We have been given the 11th term. So 11th term. So we'll say T11. 11th term is equal to 43, right? And the first term, so T1, is equal to 3, right? So how do we find the common difference? So whenever you see the term arithmetic progression, you should remember to say there is a formula, there is an equation that we use whenever we're dealing with arithmetic progressions. And that formula, that equation that we use is given by Tn. Do you remember it? Tn equals, yes, A, all right, plus, can you finish it on your own? So Tn equals A plus, open brackets, n minus 1, close brackets. Are we done? No. Multiplied by D, where Tn is the nth term, A is the first term, n is the value of the nth term, and D is the common difference. So we're asked to find the common difference. So here, what is our Tn? In this case, we have 43 as our Tn. So 43 equals, what is our A? A is simply the first term. We have 3, right? Plus, what is n? So this 43 is the 11th term. So where there is n, we'll put 11 minus 1. What is our D? D is what we're looking for, which is the common difference. So we would have 43 equals 3 plus 11 minus 1 gives us 10. Brackets, this is multiplied by D. So we would then have 43 equals 3 plus 10D. Do you agree? I hope you do. So we would have 10D equals 43 minus 3. 10D equals 40, right? And therefore D, so it's continued here, D equals 40 divided by 10, right? And therefore D equals 40 divided by 10 gives us a 4. So the common difference therefore is 4. So this is quite easy. All you have to do is collect the data, remember the formula, insert the correct data at the correct position, and from there it's just downhill. All you have to do is just work it out and do the math. So the common difference that we found is therefore equal to, so let's write it there, our common difference is 4. And we can move on to the next part, the second part of the question. The second part of the question is asking us to find the fourth term. So to find the fourth term, for as long as we deal with an arithmetic progression, we're going to use the same equation that we used, and that is Tn equals, sorry for that, Tn equals A plus n minus 1 multiplied by D. So what we're looking for is the fourth term, so we'll say T4, right, equals, what is our A? A is the first term, which we are given as 3, plus, what is our N? N is 4, minus 1, and what is our D? D is simply the common difference which we found, which is equal to 4, so we'd have 4 there. This is equal to 3 plus 3 multiplied by 4. This gives us 3 plus 4 multiplied by 3 gives us 12, and this gives us 15. So therefore our fourth term is 15. So for as long as you can remember this equation that we have here, then I believe arithmetic progression questions will forever be very, very easy for you to tackle. Nothing complicated about them. All you have to do is remember this equation that we have here, and remember to insert the correct data at the correct points, and from there it will be really, really easy for you to tackle any arithmetic progression question. We can move on to question number 9. Okay, I hope you're not tired. We still have quite a few, we still have a number of questions to go. So let's do question number 9 really fast. So the question is saying, so it's a two-part question as well. The first part, which is A, 9A, is saying a plane flying at a speed of 900 knots takes 5 hours to fly from town A to town B. Calculate the distance between the 2 points. A plane flying at speed of 900 knots takes 5 hours to fly from town A to town B. Calculate the distance between the 2 towns. So we have speed, which is equal to 900 knots. We have the time taken, which is t, equal to 5 hours, right? And we're asked to find the distance, which we will denote by or with a d. So from your grade 8, from your grade 7, I believe you remember to say speed equals to, yes, speed equals to distance over time. And in this case, we're looking for distance. This is a very easy question. In this case, we're looking for distance. So you would have to say distance equals speed times time, right? So in this case, we would have our distance being equal to, what is our speed? Our speed is 900 knots. So, okay, let's just leave it like that. We not say it's knots. And our time is 5 hours. So what is 900 multiplied by 5? So 9 by 5 gives us a 45. And how many zeros do we have? We have 2 zeros. So now, the tricky part of this question comes after you've done the mathematical part of it. You've done the calculation. So here we've done the calculations and we found, say, it's 4,500. Well, what units do we assign to this distance? We can't say meters per hour or kilometers per hour. Sorry, we can't say meters or kilometers, but we have been taught to say the speed is in knots. So whenever you see knots, the first thing that should pop into your head is nautical miles. So whenever you have a speed given in knots, it means that the distance is in nautical miles, so which is denoted by nm. So therefore, this is our distance between town A and town B, 4,500 nautical miles. So we can move on to question B, 9b. So question 9b says, point Q on longitude 85 degrees east lies on the equator and it is due east of P. The time difference between P and Q is 5 hours. Calculate the longitude on which P lies. So point Q on longitude 85 degrees east lies on the equator and is due east of P. The time difference between P and Q is 5 hours. Calculate the longitude on which P lies. So, do you remember this? When we talk of time difference, we are simply talking of a certain equation, a certain formula that we did when we're looking at this topic. And the first thing that you should remember is that the time difference between 2 points is given by the difference in longitudes between those 2 points, which we will denote as theta over 15. Why? Because remember to say for every 15 degrees, an hour is either added or subtracted between 2 points. Remember that? For every 15 degrees, there is an hour. So the difference in longitudes between those 2 points, right? And then divide it by 15. Let's say, yeah, by 15 will give us the time difference between those 2 points. So firstly, what we are going to do is we are going to replace this t with 5 hours. Why? Because we've been given the time difference between the 2 points. So the time difference is 5 hours. And what are we looking for? We're looking for the longitude on which P lies, and so we can't find this difference without that longitude. So firstly, we need to find the difference, then we'll be able to find the longitude on which P lies. So we'll say difference in longitudes. So you can denote this with whichever symbol that you want. And we would have 15 at the bottom. So the difference in longitude is therefore equal to 5 multiplied by 15. And 5 by 15 gives us 75 degrees. So 75 degrees is the difference in longitudes between point Q and point P. Okay? And you know to say that as we go to the east, time is added. As we go to the north, or to the west, sorry, we are subtracting. So firstly, let us have a visual illustration of what we have, of what we are given in the question. So we're told to say point Q is on 85 degrees east. So we have, let's say our 85 degrees east is here. This is 85 degrees east. And we have point Q there. Right? And we're told to say point P is due east of P, so point P is on the eastern side of Q. Sorry, point Q is on the due east of P, so point Q is on the eastern side of P. So meaning point P is somewhere on the west. So our point P should be somewhere here. And we'll say this is our point P. So as we move from point P to point Q, time is being added, right? So meaning if this is on 85 degrees east, meaning this one should be on something that is less than 85 degrees east. So it could be in the west, it could be on 10 degrees east, it could be on 5 degrees east, or it could be on 80 degrees east. So meaning we are going to subtract 75 from 85, because this is the difference. So we are going to say 85 minus 75, right? And this will give us 5 minus 5, 0. 8 minus 7 gives us 10. So therefore point P is on 10 degrees east, such that the difference in longitudes between Q and P is 75. And to find the time difference, we would find it to be 5 hours. So this is how we find the longitude of a point given the time difference and given the longitude of the other point in mathematics. So feel free to rewind and try to grasp the concept, and we can move on to question number 10. Okay, so I don't know if this question is as clear as I can see it, but let me just read it out. So it's a two-fold question as well, because it's got part A and part B. So for part A, it is saying the probability of a girl not wearing a necktie is 0.55. What is the probability that the same girl will wear a necktie? So let me read that again. The probability of a girl not wearing a necktie is 0.55. What is the probability that the same girl will wear a necktie? So when we talk of probability, the sum of the likely events or things that would happen is always 1. The sum of probabilities is always 1. So let me say the probability of it raining plus the probability of it not raining today is 1. So the probability of a girl not wearing a necktie plus the probability of the same girl wearing a necktie should be 1. So the sum of probabilities is always 1. So we're given to say, we're told to say probability of a girl not wearing a necktie. So let's say, how do we denote this? So not wearing, so we'll say not, okay, no, that's too long. Let's say NW not wearing plus, okay, let me write it like this. Probability of not wearing plus probability of wearing should be equal to 1. Do you see that? So the probability of a girl not wearing a necktie is 0.55. So for P and W, we'll say 0.55 plus the probability of her wearing a necktie, which will still remain as PW, is equal to 1. Because probabilities are equal to 1. So probability of wearing a necktie is therefore equal to 1 minus 0.55, right? And this simply gives us 1 minus 0.55 gives us 0.45. So this is a probability that the same girl would wear a necktie. So the key thing that you have to remember is probability, the sum of probabilities is always 1. Probabilities add up to 1. And we can move on to the second part of this question. And the second part says, given that 8 to the power x minus 1 equals 16, find the value of x. So let me write that. 8 to the power x minus 1 equals 16. Find x. X question mark. We are asked to find x given 8x minus 1, 8 to the power x minus 1 equals 16. So how do we work around this question, grade 12? You can pause the video. This is a challenge. Let us pause the video and let us see if we can work it out. So you can pause the video, try to see if you can work it out, and let's do it together. So firstly, when we're dealing with indices, whenever you're given a question on indices, the first thing that you should try to do is try to make sure that you have the same base. Okay, you have the same base. So is it possible for us to have the same base on 8 on the left side and on the right side of the equal sign? So firstly, we have 8 on this side and we have 16. What base do you think would be would we have on both sides of the equal sign? Is 4 possible? What number do we raise 4 to for us to get 8? Well, that's a bit complicated. What about 2? Or if you raise 2 to the power 3, we would have 8, right? So 2 to the power 3 is equal to 8. Okay? What about 16? How do we get 16 from 2? Well, 2 to the power 4 gives us 16. Am I right? Yes, I am. So we would then have 2 to the power 3, right? But then we also have x minus 1, 3, open brackets, x minus 1, right? And this is equal to 16 would have to be 2 to the power 4. And once you notice to say you have the same bases on both sides of the equal sign, then you can actually forget about the bases and now concentrate on the powers, on the powers that you have. So this and this are the same. So then concentrate on 3x minus 1 and 4. So we'd have 3, open brackets, x minus 1 being equal to 4, right? And we would expand that to be 3x minus 3 equals 4, and 3x equals 4 plus 3, right? So 3x equals 7. Divide both sides by 3. By 3 would have x equals 7 over 3, or 2, 1 over 3. And that is how we find the value of x. So the first and most important thing that you do is make sure that you have the same bases on both sides of the equal sign. Once you do that, it's quite easy, and you just work with the powers that you have and you get the value of x, right? We can move on to question number 11. So for question number 11, it's got 2 parts as well. And first let's see what we can do with the first part, then we get to the second part. So the first part, question number 11, the first part is saying, question 11a is saying, given that s equals, so let me just write this down so that you can have a clearer picture of what we are dealing with. Given that s equals x, which is 1 greater than x greater than 1, but less than or equal to 15, and x is a prime number. Okay, so that is what we have there. Given that s equals set s equals x, of which x is greater than 1 but less than or equal to 15, and x is a prime number. And it goes on further to say, list the elements of set S. So this is a very simple question. It it's simply asking you to list prime numbers between 2 and 15. Why am I saying 2? Because this part is saying x is greater than 1. So it's saying x is greater than or equal to 1. But it's saying greater than 1. So we start from 2 up to 15. So 15 is included because it is saying less than or equal to 15. So firstly, grade 12, what is a prime number? What is a prime number? A prime number is simply a number that is only divisible by 1 and itself. So no other number can go into a prime number apart from 1 and itself. So what numbers are only divisible by 1 and themselves between 2 and 15? Is 2 divisible by any other number apart from 1 and itself? Is 2 divisible by any other number apart from 1 and itself? Is 2 a prime number in short? Well, yes, 2 is a prime number, so set S actually includes 2. What of 3? Any other number that can go into 3? Apart from 1 and itself? No. So 3. What of 4? Well, 2 can go into 4 and 4. And what about 5? 5 is a prime number. 6. So many numbers can go into 6. So no. 7. Is 7 a prime number? Yes. 8. No. 9. Is 9 a prime number? Let us pause and think. Is 9 a prime number? Well, 3 can go into 9, so no. 10? No. 11? 11 is a prime number. 12? No. 13? 13 is a prime number. 14? What about 15 itself? Well, 15 is not a prime number, so therefore set S includes the numbers 2, 3, 5, 7, 11, and 13. So this is all that this question was asking you to do, and just for doing that, you would be awarded the full marks on this question. So let us look at the next one. So here's the question. It says the diagram below shows a pyramid, or rather shows a right square pyramid A, B, C, D, E of base 6 centimeters and EF equals 5 centimeters, right? Calculate the total surface area of the triangular faces of the pyramid. So it says the diagram below shows a right square pyramid ABCDE of base 6 centimeters and EF 5 centimeters. Calculate the total surface area of the triangular faces of the pyramid. How do you think we go around this question? So first, let us have a more clearer picture of what we're dealing with. So we have each face, each triangular face is something like that. And we have, okay, so let's take this face for instance. So we've got A there, we've got B there, we've got E there, and we have F there. And we are told this is right angle. And apart from that, we are told to say this distance, which is the base, so we'll say AB equals 6 centimeters, whilst EF, which is the height, equals 5 centimeters, right? So how do we find the surface area of just this triangle that we have? How do you find this surface area? So we know that area of a triangle equals half base multiplied by the height. So this is equal to half. What is our base? Our base is 6 centimeters. What is our height? our height is 5 centimeters, and this gives us half. 5 by 6 gives us 30, so we would have half of 30, which is equal to, so let's say A1, half of 30, which is equal to 15 centimeters squared. But we're not asked to find the surface area of one triangle, but we're asked to find the surface area of all the triangular faces of the pyramid. So how many triangles does this pyramid have? Well, this pyramid is said to be a square pyramid, so meaning it has 4 sides, 4 surfaces, or 4 triangular surfaces. So meaning to find the total surface area of the triangular faces, we would have to multiply this surface area of one triangular face by 4, because there are 4 triangular faces. So to find A dot, which is the total surface area, total triangular surface area, we would have to say 4 multiplied by A1. 4 multiplied by 15 gives us 60. So we'd have 60 centimeters squared. And that is how we go about this question. Okay, let's move on to question number 12. So here's our question 12. Question 12 is saying a function f is defined by f of x equals 2x minus 5. A function f is defined by f of x equals 2x minus 5. So this question is a 3-part question. It's got 3 parts. It's got A, B, and C. So let us start with part A. So part A is simply saying to say find f. Sorry. So A. Say A is simply saying find f power negative 1 of x. So what does this power negative 1 imply? What does it mean? So we need C functions, and the function has got a negative power, negative 1. It simply means inverse. Find the inverse of function x, function f. How do you go about finding the inverse of a function? The first thing that you do is, we've got f of x equals 2x minus 5. So the first thing that you do is you replace this f of x with a different variable. So in this case, let us say y equals 2x minus 5. So we haven't changed anything apart from giving a different variable to the function f of x. And upon doing that, the next thing that you're going to do is make x the subject of the formula. So in this case, this minus 5 moves to the other side, and you would have 2x equals y plus 5, right? And would divide both sides by 2, would have x equals y plus 5 over 2. And finally, we would replace this x with f inverse of x, and then would replace this y with an x, so x plus 5 over 2. So this is our inverse of f. This is our f of x inverse, and that is how we go about tackling question 12a. Move on to question 12b. Question 12b has got what is known as a composite function. It has to find f negative 1, 2. So f of f inverse to the power 2. Oh, sorry, f of f inverse of 2. So when you see composite functions, all you're doing is replacing the value of x with a different value, or replacing x with a different value. So in the function f of x, we've got 2x minus 5. This is f of x. And we know that f inverse of x is that. So wherever there is x in this function of x, we're going to replace with f inverse of x. So we therefore have f of x, f inverse of x, being equal to 2. There's an x there, so where there's x, we would have x plus 5 over 2 minus 5, right? This would then give us this 2 and that 2 would cancel, and would have x plus 5 minus 5, right? But then we're asked to find f. Okay, so let's leave this as it is right now. And if we simplify that, we would have x, would simply have x, right? And we are asked to find f inverse of 2. So where there's x, we would have to replace with 2. So f inverse of 2 would then be equal to 2. So therefore, that is our answer for part B of this question. And then the next part, which is part C, or part C doesn't need this, so we can create some room there and there too. Oh, sorry for that. You can create some room there. So part C is saying find the value of x if f of x is equal to x. So in the function f of x is equal to 2x minus 5. So in this function, we'll have to replace the x with this same function again. So we'll have 2, there's an x there, so we're going to have 2x minus 5 and minus 5, right? And we would have 4x minus 10 minus 5, right? But then we've been given a condition to say all of this is equal to x. So let's first start with grouping the like terms. Would have 4x minus x is equal to 10 plus 5, right? 4x minus x gives us 3x equal to 15. We can divide both sides by 3 and would have x equals 5. And that is how we find the value of x given a question as the one we've been given in 12C. So we can move on to question number 13. So here's our question number 13. So it's also a two-part question. And the first part is saying, the diagram below shows two figures, P and Q, on the X or Y plane. So we've got figure P, we've got figure Q, and well, these look something similar to me. And the question says, describe fully the single transformation that maps P onto Q. Describe fully the single transformation that maps P onto Q. So this is simply asking us to say what is going on. What is going on? What is the relationship between figure P and figure Q? Do we see any relationship between the two? Well, if we look at them closely, we'll find that this figure is exactly the same as this one, except this one is upside down, right? So it's like it's being mirrored, it's being reflected. So if we look at it critically, we'd find that the distance between this point and that point is about 1-2 units. And at exactly 2, y equals to 2, at this line, so let me do this. At y equals to 2, this point, we have a mirror line, and what is happening is that we have a reflection of P down there, because the distance from there to there, or let me say, this shape is simply being reflected down there, and this is acting as a mirror line. So what type of transformation is this? This is a reflection. This is a reflection with the mirror line at y equals to 2. So it's a reflection with mirror line reflection at, or maybe let me say reflection with mirror line at y equals 2. And that's it. You are done. We can move on to the next question. So for question number, it should be 13b. This is simply basic calculus, and something that I believe you've learned at this point as you prepare for your final examinations. So let's just run through this question real quick. So the question says, given that y equals 2x to the power 3 minus 4 over x to the power 2, find dy dx. So differentiate this expression of y in terms of x. So find dy dx. Remember, when you've got y equals ax to the power n, dy dx is simply equal to n ax n minus 1. Remember that? Okay, so let's look at this. So what we're going to do is we're going to differentiate each term independently. So for the 2x to the power 3, we are going to say this 3 comes down, we would have 3 multiplied by 2, okay, then we'd have our x, right, and then we'd have 3 minus 1, which would give us 6x to the power 2, right? Then for this second term that we have minus 4 over x2. So now remember to say, when you're interested in a denominator which has a power, when you take that denominator to, or when you make it the numerator, what happens to the power is that it will get a negative sign. So this is simply the same as negative 4x to the power negative 2, right? So then we'd have negative 2 multiplied by negative 4x to the power negative 2 minus 1, right? And this gives us 8x to the power negative 2 minus negative 1 gives us a negative 3, which is simply the same as 8 over x to the power 3. And so dy dx, differentiating this expression in terms of x, gives us 6x squared. So let me just do that. Gives us 6x squared, and this then becomes a positive, and you'd have 8 over x cubed. And that is how we go about differentiation. So we can move on to question number 14. So here's our question number 14, and the question is saying, the diagram below shows 3 points OA and B, in which OB equals AB. So we have OB being equal to AB, and given that the bearing of A from O is 30 degrees, or rather 30 degrees, and angle ABO equals 40 degrees, ABO equals 40 degrees, calculate the bearing of A, B from A, B from A. So in short, when we say the bearing of B from A, we are simply talking of, so here's our A, sorry, let's do this. The bearing of B from A, we're simply talking of this angle from this point to A, to the line AB. So when we talk of bearings, the first thing that you're supposed to remember is that in bearings, the northing is always important. So when we talk of a northing, we're simply talking of this line, a line that is vertical and is extending from a certain point on your diagram. So does A have a northing? No. So we can create a northing for A. So let's first start with having a rough sketch of what we have there. So here's a rough sketch of what we have, and we are asked to find the bearing of B from A. So as I was saying, the most important thing in bearings is that you need to have northings at points of interest. So the point of interest that we have here is A, because we're asked to find the bearing of B from A. So at point A, we need to have a vertical line which is known as a northing. So assuming we have this northing, okay, let me write it and let's have it in a different color. So assuming we have this northing at A, we have this northing at A, right? So the bearing that we've been asked to find is simply this angle from the vertical northing all the way to line AB. Okay, so asked to find this angle that we have here. So the first thing that we notice is that this triangle has two equal sides, and if it has two equal sides, it means that it has two equal angles. Okay, two equal angles. So if this is 40 degrees, we can find the remaining two angles in this triangle that we have. So to find the two angles, we would say 180 degrees minus the angle that we have, which is 40 degrees, and this gives us 140 degrees. And so to find these two angles, we would say 140 divided by 2, which gives us 70 degrees. So we have angle 70 degrees there. Let's have it in a different color as well. We'll have this angle being 70 degrees, and meaning this angle here is also 70 degrees. Let's write it somewhere down here. 70 degrees, that angle there. Okay, what else do we see? What else can we get? Well, if you can see, what we have here is a letter Z. You see that? Okay, so let me just trace it out. I'll have it, we'll erase it once we get what I am talking about. So we have this Z angle, or these Z angles. You see the Z in blue? Letter Z. So meaning, if this is 30 degrees, it means this angle down there is 30 degrees as well. So this angle here is 30 degrees as well. And if this is 30 degrees, it means this angle that is remaining up there is 40 degrees, because this is 70 degrees. You see that? So if this is 70 degrees, this is 30 degrees, this is 40 degrees. And what we're looking for is this angle from here all the way up to there, right? So how do we get this angle? Well, we know to say this northing is a straight line, the red line is a straight line, and if it's a straight line, its angle should be 180 degrees. So from that point to that point, it should be 180 degrees. But what we have is this smaller portion, which is 40 degrees. So therefore, to find this bearing, would simply have to say 180 minus 100 and minus 40. So bearing of B from A equals 180 degrees minus 40 degrees, and this gives us 140 degrees. So the bearing of B from A is therefore equal to 140 degrees. And the next part is asking us to find the bearing of O from B. The bearing of O from B. So we are interested in this line, so we need the northing there, right? So we create a northing at B, northing at B, and we are interested in this line, so we are talking about the angle from the northing all the way to line OB. So how do we find that? Well, we already know to say this angle here from the northing up to the northing is 180. So all we are interested in is this angle at the bottom there, right? The angle at the bottom. And if we look at it, we have another Z angle. Do you see it? Let's have it in a different color too. Let's have it in green. So if you look at this critically, you notice to say we have these Z angles. Do you see that? So if these angles, if this is a Z that we have, it means that these alternate angles are equal. So we have a 30 and a 70 there, meaning we should have a 30 and a 70 somewhere here, which gives us this whole angle is 100, meaning the angle from here all the way to there is 100 degrees as well. And we've agreed to say the angle from there all the way to there is 180 degrees. So meaning the bearing from O, the bearing of O from B is simply 180. So O from B equals 100 degrees plus 180 degrees, which is therefore equal to 280 degrees. So the bearing of O from B equals 280 degrees. Okay? So feel free to rewind, feel free to watch it as many times as you can until you grasp the concept. So we can move on to question number 15. Okay, so here's our question number 15. Here's our question number 15. The values of x and y are given to one decimal place as x equals to 4.2 and y equals 7.3. Find, so it's a two-part question, find A, the maximum value of x plus y, and B, the minimum value of x minus y. So this is quite interesting because when you get to understand it, you find that it's really easy. And I remember, I'm certain from your primary and maybe your junior secondary as well, you learned how to round off numbers. You learned how to round off numbers. So let's say I give you a number which is 2.7. This would be rounded off to 3. Am I right? Okay. So this is basically what we are dealing with. So let's start with 4.2. So 4.2 could have been rounded off to one decimal point, to one decimal place, and the highest that 4.2 could have been, it could have been 4.24. If I were to ask you to round this off to 1 decimal place, you would have 4.2. Am I right? Yes. And the lowest value that 4.2 could have been was, or could have been, 4.15. If I asked you to round this off to 1 decimal place, you would have 4.2. Am I right? Yes. And now let's come to the next number which we have, which is 7.3. So 7.3 could have been 7.34. Am I right? If this was to be rounded off to 1 decimal place, it would be 7.3. Am I right? Yes. And if we had to round, if we had 7.25, and I asked you to round this off to the nearest 1 decimal place, you'd have 7.3. But assuming we had 4.23, or maybe 4.25, this would have been 4.3. Or if we had 4.14, this would have been 4.1. So this is the highest, sorry, this is the maximum, and this is the minimum. This is the maximum, and this is the minimum. And the first question is asking us to say, find the maximum value of x plus y. So maximum x plus y. So this is our x, and this is our y. So for us to get the maximum value of x plus y, we would need to get the maximum value of x and the maximum value of y. So we would have x plus y max. Okay, so maximum would be let me write it down here. Would have equal to what's our maximum value of x? 4.24, right? And what is our maximum value of y? It is 7.34. When we add those two, we would get 4 plus 4 gives us 8, 2 plus 3 gives us 5, and 4 plus 7 gives us 11. Would have 11.58. And for the minimum value, minimum of x minus y. So for us to get the minimum of x minus y, the lowest value of x minus y, would have to get the minimum value of x, right? Subtract the maximum value of y. So we'd have 4.15 minus 7.34, and that will give us the minimum value of x minus y. So 5 minus 4 gives us a 1, 1 minus 3 gives us maybe we would say let's work around this so that we can make our work easier. So I was saying, for us to get the minimum value of x minus y, we would say the minimum value of x minus the maximum value of y. So we'd say 4.15 minus 7.34, right? And we can simply say 7.34 minus 4.15, and we just add a negative value to negative sign to the answer to get. So then this gives us 4 minus 5 gives us, we get a 1 from there, we get 14 minus 5 gives us 9, 2 minus 1 gives us 1, 0.7 minus 4 gives us a 3. And since we swap them, then our answer would then be negative 3.19. and that would be the minimum, or rather the lowest value that you would get if you were to subtract x from, or rather y from x. So we can move on to question number 16. So here's our question number 16, and it says it is given that y varies inversely as the square of x. The table below shows some values of x and corresponding values of y. So we have a table there which has x 2b6 and y 94a. Find the, so it's a three-part question. A is asking you to find the value of k, which is a constant of variation. B is asking you to find the value of a, and C is asking you to find the value of b. So let us first interpret the question that we have. It is saying it is given that y, so we have y varies inversely, so inversely as the square of x, so x squared, and well, that's all. So y varies inversely as the square of x, so we have 1 over x squared. And if we are to replace this with an equal sign, we would have y equals k over x squared. And these are the corresponding values of x and y. So when x is 2, y is 9. So when y is equal to 9, we have k over x, which is 2 squared. We're asked to find the value of k. So this gives us 9 is simply equal to k over 4, because 2 squared is 4. So we'd have k equals 4 multiplied by 9, which gives us 36. So the value of k is 36. So we found k, which is the constant of variation, as being equal to 36. And the next part is asking us to find the value of a. So we go by the same, y equals k over x squared. And we are looking for a. Where is a? A is there. So where there is y, we'll put a. A equals, where there is k, we'll put 36. And where there is x, we'll put 6. So 6 squared. So a equals 36 over 6 squared is 36. So a equals 1. So therefore we have a being equal to 1. Simple a. Okay. And the last part is asking us to find the value of b. And we go by the same, we have y equals k over x squared. And where there's y, we have 4. Going by the table. And where there's k, we have 36. And where we have x, we'll have b squared. So then we'd have b squared equals 36 over 4. So b squared equals 9. And so b equals, what is the square root of 9? 3. So we have the value of b being equal to 3. And that is how we go about this question on ratios, on proportions and variations, not proportions. And that is how we go about working around this question on variations. We can move on to question number 17. So here's our question number 17. So the question reads, in the diagram below, A, B, C, and D lie on the circumference of the circle with center at O. And we have that, that diagram there. And we're told to say, given that BAD, angle BAD equals 47 degrees, and angle DBC equals 28 degrees. Calculate angle BOD, angle OBD and angle BDC. So angle BOD. So we're given to say BAD is 47. Hope you can see that. And we're given DBC as 28. So angle BOD. So we have a circle, we have angles, we have triangles. You can see a cyclic quadrilateral as well. But our main area of interest right now is angle BOD, which is this one here, right? How do we get our angle BOD? Well, if we closely examine this diagram that we have, we'll find that BAD and BOD are coming from the same points on the circumference of the circle. And so this angle that we have here is simply half the angle that we have here, or the angle that we have here is twice the angle that we have at that circumference. So angle BOD equals 2 angle BAD. Alright? So what is our angle BOD? Angle BOD is therefore equal to 2 times what is BAD, 47. And 47 multiplied by 2 should give us BOD, which is 94 degrees. So therefore we have our angle BOD being equal to 94 degrees. And the next one that we have, so this is 94. The next one that we have is angle OBD. Well, OBD is a triangle. Do you see that? ODB, OBD, we have that triangle. And this is the center of the circle. This is the circumference of the circle, and so is this one. And so the distance from the circle, from the center of the circle to the circumference of the circle, is the same. So in short, we're saying this is the radius, and these two are the same length. And if they are of the same length, it means the angle at the bottom here is the same as the angle at the bottom right there. So to find that, to find those angles, we would say 180 degrees minus 94 degrees, which gives us 180 minus 94 should be 86. So we have 86 degrees. So OBD is simply equal to half of 86 degrees, which gives us 43. So this angle there is 43 degrees, and so is this one 43 degrees. So therefore angle OBD is equal to 43 degrees, because this is a triangle and the angles in the triangle should add up to 180 degrees. The last one that we have is angle BDC. So let's first identify angle BDC. So BDC is the angle. Let's use a different color for that one. BDC is this angle here. How do we get this angle, grade 7s, grade 12s? How do we get this angle? So to get this angle, we need to first acknowledge the fact that what we have here is a cyclic quadrilateral. Cyclic quadrilateral. Do you see it? And what do we know about cyclic quadrilaterals? Well, we know to say that angles that are opposite in a cyclic quadrilateral add up to 180 degrees. So if this is 47, so 47 plus this angle here should add up to 180 degrees, and this angle that we have here plus the angle that we should have there should add up to 180 degrees. So 47 plus angle BCD should add up to 180 degrees. So BCD equals 180 degrees minus 47 degrees. Minus 47 degrees, and this gives us 133 degrees. So meaning what we have here is 133 degrees. And can you finish it from there? I believe you can. Do I really have to do it? Well, let's do it together just in case you get stuck. So, well, if we have this angle and we have this angle here, and we are looking for this angle, we should realize, say this is a triangle, and angles in the triangle add up to 180 degrees. So angle BDC equals 180 degrees minus 133 degrees plus 28 degrees. You understand why we've done that? Angles in a triangle add up to 180. We have a triangle there. So this plus that should give us 180 degrees. And this is simply equal to 19 degrees. So therefore, angle BDC equals 19 degrees. And that is how we go about that. So feel free to pause, to rewind, and to watch whichever part you're stuck on as many times as you can, so that you can grasp the concept, understand it, and you should be able to solve questions on your own. So let us move on to question number 18. So here's our question 18. So it's a two-part question as well. And first let's look at question A. Question A says, the diagram below shows a right angle triangle PQR. You can see the right angle triangle there, PQR. And we're told to say, given that PQ equals to 15 centimeters and cos x degrees equals to 2/3, calculate the length of QR. How do we do it? So you can pause the video and try working it out on your own, but let's do it together. So we've been given PQ, and we've been given cos x degrees. So we know that going by SOHCAHTOA, remember SOHCAHTOA? Let's use white. Remember SOHCAHTOA, we said, remember this? Which trigonometric equation have we been given? We've been given cos. So if we have cos, we know that cos theta equals adjacent over hypotenuse, right? And in this case, we've been given cos x. X is there. Adjacent. Our adjacent is where the x is resting, and that is line QR. So adjacent QR over hypotenuse, which is PQ, right? And we know that we've been given to say this is 2/3. And we know what our QR is. Our QR is QR. It's what we're looking for. And our PQ is 15 degrees, or 15 centimeters. Well, if we have this, then we can find that given this and this, right? So we're simply saying 2/3 equals QR over 15. Do you see that? I've just lifted this part of this expression and just brought it down there, because otherwise we moved step by step. First agreed on that, then we came to the information we've been given, we replaced the adjacent with this line, we replaced the hypotenuse with this line, and we continued with what we've been given, and we replaced the adjacent with the hypotenuse with what we've been given, and the adjacent remained the same. And now we've just lifted this part of this expression and put it there. So from there, we can find the value of QR by simply cross multiplying. So we'd have 3QR. 3QR is simply equal to 2 by 15, which gives us, maybe let's write it as 2 by 15, right? So 3QR equals 30. So QR equals, what is the value of QR? Divide both sides by 3, and you would have QR equals 10 centimeters. So we have 10 centimeters at the bottom there. Quite easy, isn't it? It is easy. So that's how we work around question number 18a. We can move on to question number 18. Here's our question 18b. The question reads, the question says, a straight line L has equation 3y equals 5x minus 6. Find the y coordinate of the point where L cuts the y-axis. A straight line L has equation 3y equals 5x minus 6. Find the y coordinate of the point where L cuts the y-axis. So when you talk of cutting axes, remember the x or y plane? This is the y-axis and this is the x-axis, right? So if a line cuts the y-axis, it means its x-coordinate is 0. So this could be 0, 5, right? Makes sense. Its x-coordinate is 0 and its y-coordinate is 5. If a line cuts the x-axis, it means its y-coordinate is 0, its x-coordinate is a certain value. So this could be 6, 0. Makes sense? So at the point where a line cuts either axis, or maybe let's say at the point where a line cuts the x-axis, the y-coordinate is 0, and at the point where a line cuts the y-axis, its x-coordinate is 0. Okay, so now let's get back to this question. A straight line has equation 3y equals 5x, so 3y equals 5x minus 6, right? Find the y-coordinate of the point where the line cuts the L, where L cuts the y-axis. So where it's cutting the y-axis, its value of x is 0. So we'll simply put a 0 where x is, and we would have 3y equals 5 multiplied by 0 minus 6, and we would have 3y equals minus 6 and y equals minus 2. Do you agree? Good. So we can move on. So how we got the 2? Simply divided both sides by 3. And so the y coordinate is negative 2. And its full coordinates would be 0, negative 2. We can move on to question number. So here's our question number 19a. It's also a two-part question. It's got A and B. And let's look at A first. So we've got 19a, which is saying rectangle ABCD and DAEF are geometrically similar. Okay, so I haven't copied the whole question, just this. Okay, we've got that rectangle, those rectangles, and we're told to say, given that AB equals 10 centimeters and AD equals to 4 centimeters, calculate the area of rectangle DAEF. So rectangle ABCD and DAEF are geometrically similar. Do you see the two rectangles? We've got this rectangle AEDF, well, you get it, DAEF, and we've got ABCD. So we've got the first rectangle, which is A, B, C, D, and C. And the second rectangle, which has A, E, F, and D. And this is 4 centimeters, this is 10 centimeters, and this is 4 centimeters. Well, you notice to say this, let's call it width, and is corresponding with or to this width, and this length that we have here is corresponding to this length. It's just that this rectangle has been tilted in a certain way. So this 4 centimeters is corresponding to 10 centimeters. So we have a ratio of 4 corresponding to 10, right? And this ratio can be simplified to 2 to 5. So this is the ratio of the length of the rectangles. But we're not so concerned or interested in the length, but what we're interested in is the area, right? And to find the area of this smaller rectangle, we first need to find the area of the larger rectangle. So how do you find the area of a rectangle? Area of a rectangle is simply given by length multiplied by the width or the breadth, or let's call it B. So what is the length that we have for the larger rectangle? We have 10 multiplied by the breadth, which is 4, and this gives us 40 centimeters squared, right? But how do we find the area of the smaller rectangle? We have the area of the larger rectangle, and we have the ratio of the sides. Well, we know that to get the area given sides, we would have to multiply the length or the sides by each other, or maybe let me say, to get area, which is unit squared, we would have to get 2 units, multiply them by each other or by themselves. So to get the ratio of the area, we would have to square this ratio of the length. So we'd say area would have 2 squared to 5 squared, and this simply gives us 4 to 25, and this is the ratio of the area. And we know that this is the area of the larger rectangle, which is corresponding to the 25, but what we're looking for is the area of the smaller rectangle. So we'd have 25 is equal to 40, and 4 is equal to x, right? We cross multiply, we would have 4 by 40, 40 multiplied by 4 equals to 25x, right? 40 by 4 gives us 160 equals 25x. And you would have to divide both sides by 25, and that would give 6.4. So x therefore equals 6.4 centimeters squared, and this is the area of the smaller rectangle. So you'd have to say area equals 6.4 centimeters squared, and you are done with question number 19A. So we can look at question number 19B quick. So here's question number 19B. It says Mrs. Kalomba bought 120 shares at a nominal value of 40 kwacha each, which she later sold at 42 kwacha 15 ngwe each. Find her profit. It is quite straightforward, ain't it? We have, she bought something at 40 and Now she sold it at 42 kwacha 15 way, and she transacted 120 of them shares. Okay, so meaning for each share that she had bought, she had made a profit of 2.50 kwacha, 2.50 or 2.50 kwacha, right? This is for each share. So how much did she make for 120 shares? So we'd have to multiply the 2 kwacha 15 way by 120, right? Or we would simply, to make our work easier, we can simply say 25 by 12, right? And this would give us 10, this would give us 4, 5, 0, 5, 2. And that would give us 0, 0, 1, 3, right? Would have 300, right? So we'd have 300, and we had 1 0 here and 1 decimal place here. We can forget about the 0. So these two are simply cancelling each other out, and so therefore she made a profit of 300 kwacha in total. Very easy. And we can move on to question number 20. So here's our question 20A. Question 20A says, on the diagram in the answer space, shed 3 more triangles. Shed 3 more triangles to make a pattern with rotational symmetry of order 3. Shed 3 more triangles to make a pattern with rotational symmetry of order 3. I hope we understand what they mean by rotational symmetry of order 3. Well, to those of us that might still be behind, what we mean when we say rotational symmetry of order 3, it means it's when you rotate it. For example, you're starting, here's the center point here. If you had to rotate it from here 3 times, it would have 3, or maybe let me say, if you had to rotate it 3 times, or maybe if you had to rotate it to make a 360 turn here, it would have 3 points where it would seem to be, where it would fit perfectly. I really hope you understand what I'm trying to say. If you had to rotate this shape, it would have 3 points where it would fit perfectly, as if it hasn't been turned. So for example, what I mean is, if we were to rotate this shape up to here, this would rest there, this would rest there, okay? So meaning would have our first point, our first triangle to be shaded, which is this one. Okay. Then we need to shade 2 more. The second one will be, so if we rotate it, this will come here, then this will have to move to there. You see that? So meaning these 2 triangles need to be shaded. Yeah, something like that. So now if you were to look at it closely, you'd find that if this, once we move this part and make this part to rest here, this part would move to there and this part would move to there. Once this one moves to there, this one would move to there, that one would move to there. So it's got a rotational symmetry of order 3. And we need to meet and talk about rotational symmetry and points of symmetry, and you'll be able to get a clearer understanding of what we are talking about. So let's move on to question number 20b. So here's question number 20b. The question says, simple interest is given by the formula I equals PTR over 100. Complete the flowchart in the answer space below for calculating simple interest. Simple interest is given by the formula I equals interest equals principal times time times rate over 100. Complete the flowchart in the answer space below for calculating simple interest. So in dealing with flowcharts, each shape has got a meaning. This, for example, is signaling the beginning or ending of a process. This is signaling input or output. This one is showing a process that is taking place, and this one, or a process or an action, this one is showing is the same as this one, and so it's showing either output or input, and this is the same as that one, signaling a beginning or an ending of a whole process, right? So we're asked to complete the flowchart. So as I said, this is an input box or input shape. So here we are going to write to say the user or whoever or variables or values have to be entered. So we're going to say enter what coefficient, what variables do we have? We've got P, we've got T, we've got R. We can't say I because I is what we are looking for. And we can enter the 100 as well. So enter 100, 100 isn't a variable, so we'll say enter the variables that you have, which are P, comma, T, comma, R. So 100 is a constant, so we don't have to enter it at this point because it's part of a formula that we have. Then we'd say this is showing an action that is taking place. So I equals P star T star R over 100. So this is showing to say an action is taking place. P multiplied by T multiplied by R. So you don't just write PTR, but you need to tell the computer to say what is happening is we are multiplying. So how do we show multiplication? By using stars or asterisks, as they are commonly or fondly known as. And once you enter these two, and you are done, and you get the full marks on this question. So all you have to remember is that these shapes have meanings, and you have to input the correct action that is taking place at each stage correctly. Okay, so now we can move on to question number 21. Okay, can't believe we've reached this far, and we are on question 21. And this question is on inequalities, and it says in the diagram below, point A is 1, 1, B is 0, 7, C is 14, 0, D is 7, 7, 0, and E is 7, 1. The question further goes on further to say, write down the 4 inequalities that define the unshaded region R. Unshaded region R. So 4 inequalities. So you got that line, that line, that line, and lastly that line. So let's start with the simple ones. Let's start with this line. Okay, so for this line, we know to say point A is 1, 1. So meaning in the Y, we've got 1. So this is 1 in the Y, right? And so we've got Y equals to 1. We've got Y equals 1, right? But then this is not an equation, but it is an inequality. And what we're interested in is everything that is greater than 1, but not what is less than 1. So therefore, Y, the first inequality that we have is Y And let's use color that we won't have to change. Y is greater than or equal to 1. Right? Sorry. Don't know. Okay. Y is greater than or equal to 1. And why we are saying y is greater than or equal to 1 is because if you were to take a close look at this line, this is a broken line. It's not straight, it's not a continuous line. And if a line is broken, it means we use the equal to, greater than or equal to inequality. Okay, so y is greater than or equal to 1. And then the next easy one that we have is this one. Sorry. And for this one, if we take a close look at it, it is passing through point D, and point D is at 7,0. So D is at, this is simply x is equal to 7, right? But which part are we interested in? Is it the greater than or less than 7? We're interested in the less than 7. So therefore, x is less than or equal to 7. That's the second inequality that we have. If we look at the next easy one that we have is this one. This one is passing through the origin, which is 0,0, and point A, which is 1,1. So we can form an equation for this line passing through 0,0 and 1,1. So we know that it's passing through 0,0 and 1,1. This is the x, this is the y. We can find the gradient by saying m equals to x minus x, m equals y minus y over x minus x, right? And we say 0 minus 1 over 0 minus 1, which then gives us a 1. And you know that the equation of a line is given by y equals mx plus c. And we know that when y equals to 1, our gradient is 1, our x is 1, and our c is what we're looking for. We would have c equals 0. So we have the equation y equals x. But what are we interested in? Is it the greater than or the less than? We're interested in the parts that have x being greater than y, aren't we? We're interested in the parts that have x being greater than y, because if we were to pick this point, this is our point of interest, E. At E we have 7,1, and x is greater than y at that point. So we have x being greater than or equal to y. That is what we're interested in. The last line that we have is this one. This line is passing through B, which is 0,7, and it's also passing through C, which is 14,0. So we have our x and our y. So gradient equals y minus y over x minus x, and we have 7 minus 0 over 0 minus 14, which then gives us negative 1 over 2. Am I right? I believe I am. So we would have y equals mx plus c, and when y is 7, our x is 0, our m is 1 over 2, 0 plus c. So therefore our c equals 7. So we would have an equation which is y is equal to negative 1, negative x over 2 plus 7, right? Now, which part are we interested in? Is it this part or that part? So we would pick any point, let's say 0, 0, and we would test it out. We would have 0 equals 0 plus 7. So we would have our sign facing this direction. So we would have y is less than negative x over 2 plus 7. And those four are our inequalities for this diagram that we have on question number 21. We can move on to question number 22. Here's question 22a. So 22 has got a and b. So let's start with a. We've got solve the equation x squared minus 7x equals 8. So what do? We have everything on one side. Minus 8 equals 0, right? And we see if we can find the product and the sum. Remember, product, sum. And if we say 1 multiplied by negative 8 gives us product of negative 8. And the sum would be negative 7. So what numbers do you multiply to get negative 8 and add to have negative 7? Well, if you have 1 multiplied by negative 8, you would have negative 8, right? And 1 minus 8 would give you minus 7. So our two numbers are 1 and negative 8. So we will have x squared plus x minus 8x minus 8 equals 0. We would have x plus 1, close brackets, minus 8, open brackets, x plus 1 equals 0, right? We will have x minus 8 multiplied by x plus 1 equals 0. So x minus 8 equals 0, or x plus 1 equals 0. So x equals 8 or x equals negative 1. And therefore, that is how we solve that equation. So feel free to watch it as many times as you can until you get it right. We can move on to question number 22b. So here's our question number 22b. Question number 22b says the diagram below is a graph of y equals negative 4, open brackets, x minus 1 over 2, close brackets, squared, plus 9. And we have that diagram there. And we are asked to say find the x coordinates of A and B and the coordinates of C. How do we tackle this question as grade 12s and as people who are preparing to write our grade 12 final examination? So let's write down the equation first. We have y equals minus 4, open brackets, x minus 1 over 2 squared plus 9. We have the first part, which is asking us to find the x coordinates of A and B. But what do we notice about points A and B? Well, points A and B align on the x-axis. And if these points align on the x-axis, it means the value of y at both points is 0, right? So we'd simply replace the y with a 0, and maybe let's write it like this: minus 4, open brackets, x minus 1 over 2 squared plus 9. Replace the y with a 0, would have 0 there. And I know at this point, if you were in an examination and you came across this equation, you'd feel it's really tough. But it's actually really easy, and I want you to follow me closely. So what we'll do is we'll move this 9 to the other side of the equation, to the other side of the equal sign, and we would have minus 4 x minus 1 over 2 close brackets squared equals minus 9, right? Then what do? Well, we can divide both sides by minus 4 and would have x minus 1 over 2 squared equals minus 9 over minus 4. Well, the minus signs would disappear. X minus 1 over 2 squared equals 9 over 4. Am I right? And we can find the square root of, we can introduce the square root on both sides of the equation. And we would have x minus 1 over 2, the square and the square root disappear, and we would have root of 9 over root of 4, and this is simply equal to 3 over 2. So we would have x equals 3 over 2 plus 1 over 2. Well, this is plus or minus. So we'd have 3 over 2 and x equals minus, let's say 1 over 2 minus 3 over 2. Okay, we've run out of space, and we would have x equals 3 over 2 plus 1 over 2 will simply give us 4 over 2, and this 4 over 2 is simply equal to 2, right? And we would have 1 minus 3 gives us minus 2, and minus 2 over 2 would simply be equal to x equals to minus 1. And those are the values of the x coordinates at A and B, so therefore would automatically guess to say at A x equals minus 1 and at B x equals 2. So let's see how we can work on part 2 of this question. Okay, let's look at part 2. Part 2 is asking us to find the coordinates of C, and for the coordinates of C we know that, okay, so let's rewrite the equation first. Y equals minus 4 x minus 1 over 2 squared plus 9. And for C we know that at C the value of x is 0. So we'd simply have to replace the x with a 0 and would have y equals minus 4 0 minus 1 over 2. This is 1 over 2 squared plus 9. It would have y equals minus 4 minus 1 over 2 squared plus 9. And then we would have minus 4 multiplied by, this will simply give us 1 over 4 plus 9. And we would have y equals minus 1 plus 8. We would have y equals, minus plus 9. And once we work that out, we would have 8. But the question is asking us for the coordinates of C, so the coordinates of C would therefore be 0, 8. And that is how we work around question number 22b. Let's move on to the last question, and we will call it a wrap with this paper. So, ladies and gentlemen, we are doing the last question, and I'm so excited. I'm super excited. So here's our question number 23, which says, a sprinter runs a race of 200 meters. Her total time for running the race is 25 seconds, ending at u equals m meters per second, at u meters per second. Below is a sketch of the motion of the sprinter. We have that diagram there, and the question says calculate the acceleration in the first 4 seconds. So let's go to our diagram, and we have the first 4 seconds right there. At that point we have a triangle, we have the speed, we have the time, and we know that acceleration is simply the change of velocity with time. So we'll say the final speed minus the initial speed over time. So we would have, at that point, at the 4 seconds, the sprinter was at 9 meters per second minus the initial, which is 0, over the time, which is 4. So her acceleration actually is 9 over 4, which is equal to 1 over 4 meters per second squared. So acceleration equals 1 over 4 meters per second squared. The second question is asking us to say find the distance covered in the first 20 seconds. The first 20 seconds go up to there, and we have that shape. So to find the distance given a speed time graph, all you have to do is find the area of the shape that you have. So in this case we have two shapes. We have a triangle there and we have a rectangle there. So we would have to find the area of both shapes and add them to get the sum, which will give us the total distance covered in that time frame. So the first area that we're going to find is the area of the triangle. So to find the area of the triangle, we know that the formula for area of a triangle is half BH. And this gives us half. We have 4 and we have 9. And then this gives us half 36, which gives us 13. This is our area 1. Our area 2, which is the area of the rectangle that we have, is BH, which is 20 minus 4, because it's moving from 20, or rather from 4 to 20 seconds. So it's 20 minus 4, which gives us 16, multiplied by the height, which is 9. And 16 multiplied by 9 gives us 16 multiplied by 9 should give us that's 144. So this gives us a 144, right? So this is our area 2, and so the distance that she covered in the first 20 seconds is 144 plus 13, and then this gives us that's 7, that's 5, this gives us 100. Sorry, made a mistake. This is supposed to be 18, and this is supposed to be 18, and this gives us then 162 meters. So the total distance covered is 162 meters, right? And the value of u, where is u? Where is u? Where is u? Where is u? There is our u. Okay, so let's create space first. Create space, and now let's brainstorm. Let's think of how we can get the value of u. So we know that her total distance that she had to cover was 200 meters, and the first 20 seconds she covered 162 meters, meaning we can find how much distance she covered in the last 5 seconds. So to find that, we'd simply say 200 minus 162, and then this gives us 38 meters. So meaning the area of this shape that we have here is 38 meters. But what shape do we have here? Well, this is a trapezium, and you know that the area of a trapezium is given by half let's call this distance h, half h multiplied by this distance, which is a, plus the shorter distance, which is b, right? We know that the area is 38 equals half. This distance we have is 5, and we know that this longer part is 9 plus a, right? And we would have, sorry for that, and we would have, if we multiply both sides by 2, we would have, if we multiply both sides by 2 to get rid of the half, we would have 38 multiplied by 2, which gives us 76, equals 5 by 9 plus a. 76 equals 45 plus 5a. And 76 plus 45 gives us 121 equals 5a. And we divide both sides by 5, gives us 24.2. And therefore, I think we made a mistake somewhere. Just a second. Sorry. I think we are all tired here. Made a mistake, and we are supposed to so we are supposed to have 76 minus 45 equals 5a. So we are supposed to have 76 minus 45 equals 5a, and this gives us 5a equals 31, and a would then be equal to 6.2. So therefore the value of u is 6.2 meters per second. So we are done with this paper, and thank you very much for sticking around, and I hope it's helpful. It's been helpful, and I hope we will interact more. Thank you very much, and all the best in your exams, and bye from me.